Hello friends, in this video I will explain about relation and function. Okay, so as you can see on your screen, so what is relation? Now I will explain by you giving an example so that you will understand in a better way. Then after I will define the relation. So here you can say here two here given two sets. So now first a and a1 and the second it is a2. And the condition, so what is relation? It is a condition or limitation imposed on x and y by equation. Means any equation it is given. Okay, if on that equation, so now this is the equation x plus y equals to 6, some type of condition condition or limitation is imposed, then that equation will give the relation. Okay, so I will show you how. So here x plus y equals 6. So this is what type of equation, and if some condition if I'm going to impose on this, then in that case it will become a relation. So what type of condition or limitation I'm going to impose on this equation? So now subset of Cartesian product a b. So now you can see here x plus y equals 6, so it means the sum. So this is the condition. So condition here it means x plus y, so the result should be addition of the value of x and y should be equals to 6. Okay, not less than 6, not greater than 6, it must be 6 only. So now you can see here, if it is, it should be 6. Then here you can see here whatever elements are present here, 1 2 3 4 in a1, and 8 in a2, 1 2 3. So we have to add the elements. So 1 plus 1, so not possible, so only two elements up. If we add two set of elements, just like 3 plus 3, so we will get 6. So this is the first, and 4 plus 2, that is the 1 equals 6. And if you make pair of other elements, then you will not get the sum of those two elements as 6. For example, 4 plus 3 you will get 7, 3 plus 2 you will get 5. So that type of thing, you will get greater or less than, but you will not get equals 6. So that's why this is the condition imposed. So that's why this is representing a relation. And on the graph you can see here, if we plot the all ordered pair, so I have already explained how to find out the, you know what, the Cartesian product. Okay, so Cartesian product you can represent on the graph like this. Okay, here you can write on 0. So along x-axis you have to represent the first set, and along y-axis you have to represent the second set. And then if you plot the graph, then you will get like this. Okay, so only these two means now you can see 3 comma 3. So 3 comma 3, so 3 comma 3 and 4 comma 2, only these two ordered pair represent the relation, and others are not representing the relation. Others are ordered pairs of Cartesian product but not the relation. Only these two giving the relation. So now you can see 3 comma 3. So 3, now you can see go along x-axis 3, and then along y-axis you have to go 3, so you will reach here. So this is it. So this is 3 comma 3, and the second is 4 comma 2. So 4 along x-axis you have to go 4, and then along y-axis 2, 1 2, so here you will reach. So this is the second pair, ordered pair. Okay, so these two pairs, so we can represent by using relation. Understood? Now here it is written, any non-empty proper subset R, okay, of the Cartesian product. So it means whatever it is, relation is always, you know what, relation always comes under Cartesian product. If two sets are given, the Cartesian product subset of the that Cartesian product will give the relation. Inside that Cartesian product we will get the relation. Okay, so that's already written, non-empty. So here a1 and a2, so two sets are given. If you find out the Cartesian product of these two sets, so you will get okay, it is better to write down here by using curly bracket. Okay, because nowadays generally we use curly brackets to represent set. So here any non-empty proper subset R of the Cartesian product AB is called relation from the set A to the set B which satisfy the given condition. Okay, so that's it is. So What is relation? Relation is the subset. Okay, relation is the here it is given proper subset of the Cartesian product AB which satisfy the given condition. So here in this case you can see the Cartesian product. So this relation, so this is the condition x plus y equals 6. So this is the condition or limitation imposed on the Cartesian product. Okay, and since this condition or limitation is giving us the, you know what the result, this condition is satisfying the given Cartesian product, or it is coming under Cartesian product, or it is, in other words you can say it is the condition giving two results, so 3 comma 3 and 4 comma 2, and these two pairs are proper subset of given Cartesian product. So that's why this is a type of relation. Okay, then after the comes the domain of a relation. Domain means in the Cartesian product the set of all the first elements. Okay, so here two sets are given. Okay, if you find out the Cartesian product, then you will get the first element and the second element in all those sets. So the set of all, what I said, the set of all first elements of the Cartesian product. Okay, for example here two Cartesian product given, so in the first element will be 3 and here 4. So the set of all first element of the Cartesian product is the domain of the relation. Okay, is the domain of the relation. Now you can see here is the definition. And the range is the, what is range? The set of all second elements of or ordered pairs x y which belong to the relation is called the range of the relation. It means the set of all second elements or ordered pair which belong to the relation is called the range of the relation. I will explain by giving example. So this is example. So this is set A and we are finding the Cartesian product of A into A. So we got this. Okay, so we got this. This is what you can see, not able to see. So now you can see here. So now you can see here. So A. So now Cartesian product we got here, and R is given by, means now the condition is that y should be less than x, or you can say x is greater than y. So this is the condition, and accordingly we have to find out what are the elements or what are the ordered pair. So here x comma y, and then condition is x belongs to A and y belongs to A, because we are finding here the Cartesian product of A and A into A, and another condition is here y should be less than x. Okay, so from this Cartesian product we have to see that where the value of y is less than x. So now you can see here 2 comma 1. So here y is 1, so 1 is less than 2. So again here 1 is less than 3, 1 is less than 4, 2 is less than 3, 2 is less than 4, 3 is less than 4. So this is it. So in this way you can see here, so in these all ordered pairs the value of x is greater than y. So this is satisfying the condition. So this is what the relation. Okay, so this is the relation. Cartesian product, it is whole, means these all are simply multiplying, or you can say you finding the ordered pair, that is the Cartesian product. And if it has to be a relation, then in that case there must be some type of condition or limitation, and that condition limitation here in this case it is y less than x. Okay, so now you can see here, so according to this limitation we are getting this one, and this notation I have already explained. So this is it. And if we have to find out the domain and range of this relation, then how to find out? Now you can see what is the domain. Domain is the first element, set of first element of all this ordered pair. So now you can see here as I have already explained. So now the first, what is the domain? The first set of first element of all ordered pair. Now you can say set of first element. So now here it is, first element is 2, 3 4 3 2 4 3. It means we don't repeat. Okay, so we can say 2 3 4, 2 3 4 only. So it means the domain it will be 2 3 4. Now you can see here domain it is the set of 2 3 4. Okay, in the same way the range it will be the second element of the. Now you can see here the second element here it is 1 1 2 3. So 1 2 second elements are, you know what, 1 2 3 you can find out here it is 1 1 1. So 1 1 means, so only one time we have to write down 1, then 2 2, so only one time we have to write down 2, so 1 2, and then in the last it is 3, so 1 comma 2 comma 3, that it should be the range. So now here it is range, it is the set of second element of the ordered pair. Okay, now next here it is about the functional relation. Okay, so what is functional relation, that's I will explain first. Okay, so here now you can see here some definition, other so many different in so many different way the same thing explained. Okay, so I will explain by any practical way. So a relation, okay, a relation, what is a relation? Subset of Cartesian product, that's I have already explained. This is a type of subset relation, is a functional relation if no two distinct ordered pairs of the relation have the same first component. Okay, here it is given, if you got ordered pair, okay, by Cartesian product, and in that condition is that whatever it is the condition, if inside that condition if no two element, okay, the first element two Cartesian product should not be the same element. Okay, then in that case it is going to be known as functional relation. So and if two or more first elements of the ordered pairs are going to be the same element, then in that case that is not functional relation. I will show you here. For example, if any condition, if any condition or limitation giving us these two product, okay, these two ordered pairs, just like 1 comma 2 1 comma 3. So here you can see the first element in both are same, so that's why this cannot be a function. So here you can see here in another way I can explain. A relation is a functional relation where for each x, or several as for each x meaning the first element of the ordered pair, there is only one corresponding y. It means for each x there should be only one y. Okay, if other than this condition is there in ordered pair which we get from the given limitation, then that is not going to be known as functional relation. Okay, so this is it. So this I will explain by giving example. So function is defined, so now you can see a function is defined in this way: y equals f, and inside bracket we write down x. Okay, so it means y is a function of x, so f for function of x, so y is a function of x where x is known as independent variable and y is known as dependent variable. Okay, because the value of y is depending on the value of x. So here one example here I have explained, so here everything will be clear. So here two sets are given, a and b. Okay, so set set a here given, set b, so x here belongs to set a and y belongs to set b. So condition here it is given, so condition or limitation, so that's you already know. So whatever it is the condition or limitation, that is known as relation. Okay, so these all are relations. So whether these relations are functions or not, so that's what we have to prove, so we have to show. So here do these relations define functions? So whatever you write here, so that condition means those conditions are going to be called as relation, but those limitations or conditions are not function until this condition means the condition which I just now explained, that is going to be satisfied. So first here the first condition, y equals x square. So y equals x square, So now we have to see y. So y means here you can see here y belongs to b. So here you can see y. So y I can write on only one here, one. Okay, if you write on one here, then value of x. Value of x you should take, so that square of that x means x square, you will get 1. So it is only 1, because square of 1 you will get what, 1. So x square means 1 square, you will get 1. Okay, so this is the only case, and you can find out the other value. No other values, no other value of y uh, is equal to you know what, the x square value. So x square means you do 2 to the power 2 here, so you will get 4. So there is no 4. So here 3 to the power 2, you will get no 9. So in the same way you do the square of all other elements, you will not get the result from here. So that's why the domain is 1 and range is 1, since uh, in this case each element in the domain, you know what, correspond to, you know, unique value in the range. So that's why this is a functional relation. Okay, so since the element in domain has unique value of range, so whatever it is in the domain, for that element there is unique value in the range. So that's why this is an example of, you know, functional relation. Okay, in the same way the second condition is given y equals x. Second condition here, it is y equals x. Here you can see here the second condition, it is second relation, it is y equals x. So now we have to see that whether y equals x is a function or not. So now you can see here, so y equals x. So if you check in these two sets a and b, so you can see one is common, so 1 here, x1 y1, so 1, this is the first. 2, so 2 is present, so 2. Other than 1 and 2, there is no element in these two sets which is common. So that's why we can write down the relation is y equals x. So x1 and 2, so for this 1 and 2, the value of here y, it is 1 and 2. So now you can see for each value in the domain, so domain means the value of x, there is unique value in the range, means value of y. So that's why this is a type of function. Okay, so y equals x, this relation is a function. Okay, so now next here if you find out, so the third relation, it was x square equals y. X square equals y. So you simply write down the values of y. If you can write down the first, or you can write the value of x. It depends on you, as it is easy to calculate. So first if I write down the value of x or value of y. So now value of x, if I write, so value of x 1, so square root of this will give minus plus minus 1, so this is minus 1 also. So now square root of this 4, square root of 4, because value of x here, because in x 4 also present. Now you can see in x 4 also present. Okay, so we have to take elements in x from there, from set A. So square root of 4, you will get plus minus 2. So plus minus 2 means minus 2 is also there. So in the same way 1 again, so here you will get 4 minus 1 minus 2 you got. In the same way you will get plus 1, because square root of 1 you will get plus 1 also. And here square root of 4 you will get plus minus 2. So minus we have already written there, so here we are writing plus. So this is the head. So now you can see here here these two, because since we know that we don't have to repeat in case of set, so these two are same. So 1 1, so the same. So for each one, for element 1, there are two range value, minus 1 and plus 1. Okay, so this is the domain, this is the range. For each value in the domain, there are two values in the range. So it means this is not a functional relation function. Why? Because two values we are getting in the range, so we have to get only one. If more than one we are getting, then this is not a, this condition is not a function, this is only the relation. So it means we can say that x square equals y is a relation but not a function. Clear? So I hope it is clear. Thank you all. So please like, subscribe, share for watching such informative videos on mathematics. Thank you.